Hey everyone. So today we're going to pull back the curtain on the apps you use every single day. We're going to explore the hidden blueprint, the invisible architecture that makes them work, or in some cases, fail in the most spectacular ways. Picture this. It's January 13th, 2018. This exact message flashes across the phones of 1.4 million people in Hawaii. For 38 absolutely terrifying minutes, an entire state was convinced a ballistic missile was about to hit. It turned out to be a false alarm, a mistake. But man, it leaves you with a chilling question. I mean, really think about that. How can one person clicking one button on one screen send an entire state into a full-blown panic? The answer isn't about blaming the person who clicked it. Nope. It's about blaming the blueprint, or maybe the lack of one. And that's exactly what we're going to unpack here.
So what is this blueprint I keep talking about? Well, there's a whole discipline dedicated to designing our digital world to prevent exactly this kind of disaster. It's called software design. It's the architecture of everything we use.
Think of it like this, right? Before anyone even thinks about laying a single brick for a skyscraper, you've got a super detailed blueprint. Software design is that blueprint for an app. It's the crucial step where you figure out how the whole thing is going to be built before anyone writes a single line of code. Why? Because changing a line on a piece of paper is cheap. Trying to change the foundation of a skyscraper after it's been built? Yeah, that's pretty much impossible. And this is basically how an idea turns into something real you can use. You start with the what, the requirements. Then you sketch out the high-level architecture. But this step right here, step 3, design, that's where the magic happens. Or where it all falls apart. Getting this middle part wrong is like having a beautiful drawing of a house, but no plan for the plumbing or the electricity. It's where these huge, costly, and sometimes catastrophic mistakes are either made or avoided.
Okay, so how do you actually create a good blueprint? Well, it really starts with your building materials. You need strong bricks and you need smart connections, basically independent pieces that know exactly how to talk to each other without causing a mess.
This whole idea is called modularity, and the analogy here is perfect. Instead of trying to build your app like it's one giant, solid block of marble, you build it out of smaller, interchangeable parts, just like Legos. This makes the whole system way easier to build, so much easier to fix when one little piece breaks, and a lot easier to update down the road. So to make this Lego idea actually work, you're aiming for 2 things. First is high cohesion. This just means that everything inside one of your Lego bricks is all related and serves one single purpose. Think of a well-organized toolbox where all the tools are for plumbing, they just belong together. The second thing is loose coupling. This means the bricks connect in simple, standard ways. They don't need to know about the messy inner workings of the other bricks. It's the difference between easily plugging in a string of Christmas lights versus trying to deal with that giant, tangled, interdependent knot of wires. So how do all these separate little modules actually talk to each other? They do it through something called an API, an application programming interface. An API is basically a formal contract. The best way to think about it is like a restaurant menu. The menu tells you exactly what you can order from the kitchen and what you're going to get back. You don't need to know how the kitchen works at all. And this is so important because it means the kitchen can completely change. They can get new chefs, new ovens, whatever. But as long as the menu stays the same, you, the customer, will never even notice. But look, just building with perfect, independent modules, it's not enough. Because in the real world, things break all the time. Networks go down, users make mistakes, data gets corrupted. A truly great design doesn't just plan for a perfect sunny day. It assumes the storm is coming, and it prepares for it. This is one of the most haunting examples in the entire history of software. The Therac 25 was a radiation therapy machine. When it had a problem, it would display these really vague, cryptic messages, like malfunction 54. The operators, who saw this all the time, just learned to ignore it and move on. But behind that simple error message, the machine was delivering lethal doses of radiation because of a software bug. The Therac 25 story is just a horrifying lesson in why error handling is absolutely non-negotiable in good design. It's not some afterthought you tack on at the end. It's the proactive process of thinking through every single way something could go wrong, and then planning exactly how the system is going to respond, safely and clearly, so that something like a malfunction 54 can never, ever happen again. And that brings us to the message itself. The difference between a bad error and a good one can literally be life and death. A bad one is cryptic, unhelpful, and it leaves you feeling powerless. But a good error message, it's descriptive, it tells you exactly what went wrong, it's actionable, it suggests how you might fix it, And it's clear so that absolutely anyone can understand what to do and feel like they're back in control.
So professional designers follow a few key strategies to build this kind of resilience into their apps. The first one is fail fast. It sounds a little weird, right? But it just means the system should flag a problem the absolute instant it happens. This prevents a tiny little glitch from snowballing into a massive system-wide catastrophe. Then there's graceful degradation. This just means that if one part of the system fails, the whole thing doesn't just crash and burn. It's why your social media app might show you old posts from its cache instead of just a blank screen when your internet is bad. And finally, a consistent strategy. This is all about building trust, so users aren't confused by 10 different kinds of error messages in the same app.
Okay, so now we get to the most critical and honestly the most overlooked part of any system, the actual human being who has to use it. Let's circle all the way back to that Hawaii alert. The investigation found that the design was the real bad guy here. The interface for sending a test alert looked almost identical to the one for sending a live alert. There were no big confirmation steps, no "are you sure" pop-up, and worst of all, no easy, obvious cancel button. The design made it incredibly easy to make a catastrophic mistake. And this is where the field of usability engineering comes in. It's a whole science dedicated to making technology work for humans, not the other way around. At its core, it's really about empathy. It's about understanding how people think, how they behave, and then building the software to match that. Now, usability isn't just some vague feeling like, oh, I like this app. It can actually be measured across these 5 areas. That Hawaii system, it failed catastrophically on learnability. The interface was so confusing, a user couldn't tell a test from a live alert. And it completely failed on errors. I mean, not only was it dangerously easy to make a mistake, it was nearly impossible to recover from it because there was no obvious undo button. A good design really has to think about all 5 of these things. Okay, so if we agree that it's never the user's fault, then how in the world do we find these problems before they cause a disaster? The answer is actually so simple, but it's amazing how often it gets ignored. You have to watch real people try to use your creation. You don't ask them if they like it. You give them a task like, hey, try to buy a train ticket to Boston. And then you just watch, silently. You see where they get confused, where they pause, where they click the wrong thing. And those little moments of friction, they aren't failures of the user. For a designer, they are pure gold. They're the flaws in your blueprint that you can now go back and fix. So after looking at the blueprint, the ways things can fail, and the all-important human factor, what's the big picture here? What's the final takeaway? Good design is never an accident. It's a thoughtful, deliberate, and honestly, an empathetic process. When it's done right, you don't even notice it. Technology just feels easy, it feels safe, it feels obvious. But when it's done wrong, as we've seen, the consequences can be absolutely enormous. And that brings us to our final thought. The next time you're using an app and you feel frustrated, or maybe you use one that feels incredibly simple and elegant, just take a second. Try to look past the screen and ask yourself, what are the invisible design decisions that are shaping this experience for me right now? You might be surprised by what you find.